Let's see what results when we equate a couple of familiar equations. Recall that acceleration equals delta v over delta t. Also recall that the acceleration is equal to F over m, Newton's second law. Let's equate the two acceleration equations. Multiplying both sides by m delta t, we get F delta t equals m delta v. Or we can say F delta t equals delta mv, which happens to be an intriguing relationship. The quantity F delta t is called impulse. Or letting delta t simply be t for the time interval, we can say impulse equals ft, which is read impulse equals force F exerted on an object multiplied by the time it acts, t. The quantity mv is called momentum, which is inertia in motion. A massive object at rest has inertia, but no inertia of motion, which is to say, no momentum. But apply a force to it, and it acquires momentum. Better said, apply an impulse to an object and it will undergo a change in momentum. Impulse equals change in momentum. Or in symbol form, Ft equals delta mv. We say the impulse exerted on an object changes the momentum of the object. Ft equals delta mv is called the impulse-momentum relationship. Both impulse and momentum are vector quantities. Direction matters. We can apply this relationship to the unfortunate situation of being in a car that goes out of control and is brought to a halt by a collision. In any case, the impulse of the collision will bring your momentum to zero. Suppose the collision is with a haystack. Then the impulse, force times time, is mostly in time, which is a good thing. Note the long time means a small force for a given impulse. But suppose the collision is with a stone wall. Whoops! Here the impulse is mostly force because the time during which the impulse occurs is short. Big Ft equals delta mv. So minimum force occurs when the time of contact is long. No matter how the car is stopped, the impulse Ft is the same. In boxing, consider the momentum of an incoming punch. When the boxer moves away from the punch, he extends the time of contact and diminishes the force. Big T means small f. When he moves into the glove, the time is reduced and he must withstand a greater force. Small t means big F. In our next lesson, we'll see that if there's no net impulse on an object, then its momentum will not change.